Okay. Hello, welcome everybody to the short paper session, Analytics and Applications. My name is Anna Vilanova, and I'm a professor at the Eindhoven University of Technology. And I have the pleasure to be the chair of this session with very diverse and interesting papers. So to get started, I would like to start with the first paper. The first presenter is going to be Yikai Lu. He's going to present a paper of FAVis, Visual Analytics of Factors Analysis for Psychological Research. And this is work of Yikai Lu himself together with Chaoli Wang. Please go ahead. Please, you can start.
Thank you. Hello, everyone. Today, I would like to talk about FAVis, Visual Analytics of Factor Analysis for Psychological Research. In psychology, researchers are interested in studying and measuring latent variables, such as personality and intelligence, which are not directly observable unlike physical features. So psychological researchers often use common factor models to study and measure latent variables. In common factor model, latent variables are called factors, and all the edges between factors and observed variables are called factor loadings, which explain the linear association between a factor and a variable. The left-hand side shows all the observed variables, which could be subjectively rated by individuals. There are several challenges in using factor analysis. First, when researchers want to estimate factor loadings, it's called exploratory factor analysis, revealing the factor structure of variables. However, we do not know the meaning of these factors after we conduct exploratory factor analysis. This is similar to a situation where we use principal components analysis to extract low-dimensional principal components from high-dimensional data, but we don't really know the meaning of each dimension or each principal component. Second, number of factor loadings can grow quickly as it is proportional to the number of variables and number of factors. Because the number of variables can be 200 or 300, the number of factor loadings can easily be over 500. Third, the structure of a factor model can be complex. The most ideal structure will be only one significant factor loading for each variable, like this figure shows. However, practically, we could have multiple factor loadings. A large factor loadings belong to one variable, which are called cross loadings. And cross loadings make a common factor model harder to interpret. Furthermore, we could have multiple variables with the same cross loadings pattern, which can make a common factor model even harder to interpret. In this case, we can only rely on item 1, 2, 3, and 6, 7, 8 to interpret the meaning of factor 1 and 2. Finally, factor rotation can make factor loading structure simpler by allowing factors to correlate with each other. Even though we can make factor loading structure simpler, if we have many factors, such as 10 factors, we can have about 45 correlations to interpret. So it can still, the common factor model can still be very difficult to interpret. There are several problems of interpreting factors: subjectivity, misinterpretations, and over crucial information. This is an example where researchers use factor analysis. Researchers developed 14 adjective-rated scales for measuring social trade, and they initially used a 4-factor model. However, they struggled to interpret the meaning of 2 factors, and they labeled 2 factors difficult to interpret. So they ended up using 2-factor model, and they labeled each factor fear response and optimism. As you can see, whether researchers can interpret interpret the meaning of a factor subjectively is very important because it will literally affect the process of analyzing a factor model. So our approach is based on the idea of thresholding, where we can remove some of the factor loadings with the small factor loadings, small values by setting some threshold value. So FAVis has a multiple views to visualize factor loadings, while we allow users to interact with each view by linking and brushing, and also we have threshold view to control the amount of information we want to show. So in threshold view, if a user sets a smaller threshold value, FAVis will show us dense visualization. On the other hand, if a user uses a large threshold value, then FAVis will show us sparse visualization. Therefore, users can adjust this threshold value to find the optimal threshold value, which balances between interpretability and loss of information. I'll show you a demo of our tool. So we conducted user study with 5 domain experts familiar with factor analysis, and we asked them to complete 3 tasks. The results showed that FAVis was very useful for them to complete all these 3 tasks successfully, and they reported that they enjoyed to use the tool and they would like to use it in the future. So in conclusion, user study revealed the effectiveness in completing the different tasks, leading to high satisfaction. And multiple views allow users with varying levels of familiarity with visual analytics and factor analysis to accomplish tasks. There are several limitations, including factor correlation view only has one visualization modality, and the initial layout is fixed. But in the future, we would like to allow FAVis to be able to compare between different models, and in the user study, compare FAVis against the baseline, and provide an R package for FAVis to run locally. Thank you for listening to my presentation.
Thank you. Thank you very much for this nice presentation. I want to say that if you have questions, please write them down in a Slido. I will be looking at them during the talk already. Write them down because I think there is a bit of delay so that I see them on time. So we have some short time for a question. I would like to ask you, I would have a question myself. So when you have this threshold, you add some dynamics to your data, right? So you're changing your threshold, your data is changing through time. Is there properties of this dynamic change that might be interesting for analyzing the factors, or did you think about that, whether you could incorporate that or not, or was that relevant?
Yeah, I think thresholding doesn't really actually change the model. It's just whether we want to show the factor loading smaller than the sum certain threshold. However, I think the threshold. The factor loadings are very interesting because we can look at the distribution of factor loadings, and also there's a lot of rule of thumb in psychology already. Many people use 0.3, for example, and I think I think there should be some research more into how to determine the optimal threshold, even computationally, I guess. Yeah.
So it's more about determining the threshold, so you don't think that looking at the evolution of the different values of the threshold would...
Oh, I think the evolution of different value of threshold, I think if we change the threshold in the network view, if some variables have cross-loadings, then you can see that edges will connect to each other, right, to different clusters. So it's easier to notice if a variables have cross-loadings. So yeah.
Okay, thank you very much. So in Discord, maybe if you have more questions, you can answer those in Discord. Okay, thank you very much. So I would like to introduce our second speaker, who is Nicole Sultanum. I'm sorry for the pronunciation. Data guards, challenges and solutions for forecasting trust in data. This is work together with Dennis Bromley and Michael Correll. Please go ahead.
All right. Hi, my name is Nicole Sultanum, and I'm here to talk about work done with Dennis Bromley and Michael Correll about trust. There's this pervasive thought that being data-driven means you make more objective and therefore more trustworthy decisions. But in practice, making decisions with data is far from objective. Consider the scenario where you are a lead investor for a public hospital responsible for a 500 million fund. It's a big amount and there's significant impact for making a bad decision. You have a team of junior analysts working to find the best investment options, and they tell you to invest half the fund on stocks for this new pharma company that promises a massive return of investment after getting FDA approval. Do you believe it? Will you act on it? What would it take for you to make a confident, data-driven decision? In this scenario, the investor is what we call a data artifact consumer, or consumers for short, as someone who uses visualizations for data-driven tasks that were created by someone else. Consumers have a lot of domain expertise and can be very data literate, but they have limited access to the data provenance pipeline and primarily rely on the data artifact producers who may or may not understand much about the domain. This is a very common division of labor in large organizations and in consulting, and data trust is crucial in these settings. That said, a lot of the conversation we see about trust in our community is related to topics like fighting misinformation, detecting and cleaning bad data, and handling uncertainty, which are all critical for producers. But consumers have different needs, different premises, context, and level of detail, which we argue for a dedicated look on trust from their perspective and targeted solutions tailored to their needs. In this work, we wanted to better map out trust concerns and needs from a consumer's perspective. To that end, we interviewed both consumers and producers and reconciled their perspectives to identify challenges consumers face, current strategies that producers and consumers follow to mediate trust, which then led to proposing and validating tentative solutions. More details in the paper, but here's a super high-level overview of barriers we identified as having a significant impact on trust. In the domain knowledge gap between consumers and producers, the fact that consumers require significant experience to be able to tell that a VIS smells kind of funny, the reliance on human relationships as a surrogate for trust, or the I trust Wendy, the person who created this VIS, the disproportionate negative effect of broken trust, a frequent lack of transparency in documenting data metrics and processing pipelines, and the attrition that happens when data and processing pipelines change. These barriers, reframed as mitigation strategies and design goals, include ways of capturing domain knowledge, bridging the gulf of domain expertise, opening the data processing black box at the right level of detail when critical decision-making is involved, provide high-level trust signals for a quick vibe check when time is limited, signaling changes in the data and pipeline as that's when things tend to break, and building on that social trust capital to leverage interpersonal trust where relevant. Heavily informed by these findings, we conducted a creative brainstorming exercise to translate challenges and design goals into ideas for potential consumer-facing solutions for trust that we call data guards. They are grouped in 3 clusters: overview for quick high-level signals of trust, details for when more information is needed, and community, again, building on social trust. In the first cluster, data and pipeline tests build on the notion of Boolean programming assertions and can test the data quality features like presence of null values, domain knowledge features like value thresholds, or indicate what data slices are present or absent in the visualizations. The idea here is they provide deterministic and domain-relevant sanity checks on the data. The second idea is to provide a module or agent to serve as a smell detector and help the novice users in identifying things that may warrant more care or scrutiny. The third idea is automatic notifications for what and when things have changed in a data pipeline, which sounds simple, but for a lot of data analytics platforms out there, producers have to make a deliberate decision to add this information in. Moving on to the details cluster, we have explanation and status, which is about compiling consumer-facing information of data, pipeline, metrics, caveats at an appropriate level of detail. Again, this already exists to some extent, but implementations are manual, inconsistent, and there's a gap here to help producers craft or curate this information more efficiently. Some level of LLM, large language model assistance, might be helpful for producers here. Data traces is a variant of explanation and status, but it's triggered on demand and focuses on a particular subset of the data and chronicles how the data got to the VIS. The idea here is consumers could use this to look more closely at those funky smelling data points and get more tailored information on them. The third and final cluster, capitalizing on social trust. Stamp of approval is what we call top-down trust and is about increasing visibility of Wendy, that is that trusted person who manages some aspects of the analytics pipeline, and that she has verified that aspect of the pipeline. Conversely, crowd wisdom is bottom-up trust. It's an opportunity for consumers to leave some of their knowledge in the VISs by commenting, flagging issues, which can be seen by their peers, and also by the people who maintain the visual analytics pipeline. To get a sense of where implementation efforts should focus first, we asked our 10 consumers to rank the data guards in order of perceived utility to their practice in a card sorting exercise. Here we have the results with data guards sorted in descending order of rank counts. The highest ranked one is stamp of approval, which speaks to the importance of community in quick trust signals. But the following two, both under the details cluster, suggest that there are occasions when having more information is helpful and delving deeper is necessary. Overall, though, we found no clear favorites. All data guards figured the top two at least once, meaning that collectively consumers found some value in all of them. So if you want to implement any, pick your favorite. Overall, our data guards are conceived as add-ons that are pipeline agnostic and meant to guide implementation efforts. Beyond integrating data guards into visual analytics endpoints, we also see their value as brainstorm materials for trust solutions, conceptual tools to mediate conversations between producers and consumers about trust, about the domain, and for us, a slightly different flavor of trust to the broader landscape of trust for visual analytics. Here are code for the paper blog post and a shameless plug that Tableau Research is looking for summer interns. Happy to take your questions.
Thank you very much, Nicole. Thank you for this nice talk. I don't see any questions as leader, so I will get started. From these data guards that you have, which one do you consider more relevant when we try to do visual representations and our designs, or are all equally relevant?
Yes, as our assessment showcase, which was, arguably small scale, they all have some value. We hypothesized that stamp of approval and explanation and status and data traces have perhaps ranked a little bit higher than others because they are things that are currently not well supported, at least among the cohort that we interviewed. So maybe these would be good places to start. We're particularly interested, I guess, in instrumenting ways of opening the black box a little bit more, so explanation and status may be, if anybody's looking for one single place to go for, explanation and status and data traces are perhaps, really good places to start.
Okay, thank you very much, Nicole. Unfortunately, we have not much time, so I would like to move to the next speaker. Thank you very much for the nice talk. So we move further to the next speaker. The next speaker could be Shu Li. So he's going to present AltGeoViz for facilitating accessible geovisualizations. This is work done together with, I'm really sorry for the pronunciation. from multiple different authors like Yuren, Wang, Ather, Sharif, Arnavi, Chheda-Kothary, Jeffrey Heer, and John Froehlich, I would guess. So please go ahead.
Thank you. Can everyone hear me and see my screen? Okay, awesome. I'll get started. So hi, everyone. My name is Chu, and I'm a PhD student from the University of Washington. On behalf of my co-authors, I'm excited to present our project on making geovisualizations accessible. So many of you here are very familiar with geovisualizations. They're capable of communicating complex spatial patterns, revealing insights on different zoom levels, enabling interactive data exploration through zooming and panning. As we can see from this New York Times example, geovisualizations can often effectively convey how patterns change across different geographical scales. Now I would ask the audience to pause for a moment and imagine yourselves as screen reader users. So here we define screen reader user as someone who relies on assistive technology to interact with digital content, typically people who are blind or have low vision. So maybe just close your eyes for like 5 seconds and imagine interacting with geovisualizations as a screen reader user. It's not so easy, right? So to address this challenge, we created AltGeoViz, an open source system that auto-generates summaries of interactive and dynamic geovisualizations. So let's take a look at our demo.
Population density in the United States. Press H to hear shortcut keys. In the current view, population density is high in the right. Population density is low in the top left. The average population density is 253.5 people per square mile. The state with the highest population density is District of Columbia, with 10,970.5 people per square mile. The state with the lowest population density is Wyoming, with 6.0 people per square mile. Press L to hear the boundary of the current view. Press M to interact with the map.
So as we just saw here, for each map view, AltGeoViz communicates what this geovisualization is about. Here it's about the population density in the United States, the spatial patterns within this view, and descriptive stats such as the maximum, minimum, and mean values for the current view. So in our exploratory user study, participants responded favorably to AltGeoViz, saying it enabled new interactions with geovisualizations they had not previously experienced. So one of the participants said that one of the classes that he wanted to take in grad school was Geographic Information Systems, or GIS, but he had to forego taking the class because there was nothing like our system back then. So how do we do this? First, based on prior work, we identified 5 key elements to communicate to screen reader users: the heading, the boundary, the zoom level, descriptive stats, and spatial patterns. So let's take a closer look on how we generated spatial patterns. So we first define a bounding box. It's either the entire data set or the current viewport. We then subdivide this box into a 3x3 grid, creating 9 cells. For each polygon in our data set, we compute the centroid and assign it to a corresponding grid cell. Within each cell, we aggregate data values and calculate the mean. We then rank the cells based on their mean values, where 1 represents the cell with the highest mean and 9 the lowest. So to simplify, we group cells based on value similarity and spatial adjacency. This allows for the system to output natural location descriptors like top right instead of cell numbers. So for example, if we're looking at a population density map of the US here, the 4 cells in the top right corner are ranked 1 through 4. The system would report that in this view, the population density is high in the top right. So let's take a look at how users interact with the system.
Map region, now interacting with the map. Zoomed in, now at state level, centered on Kansas. Press I to get more information. Moved right, centered on Missouri.
So the users would zoom and pan like non-screen reader users would do. And then whenever they zoom or pan, they will hear the center location of the current view as well as the current zoom level. So many times only knowing the center location and the zoom level is not enough for the users to know where exactly they are. And to address this problem, we implemented the feature where users can always press the L key to hear the boundary, which includes the four corners of the current view.
The current view is bounded by Fall River County, South Dakota on the top left, Lambton Shores, Canada on the top right, Spartanburg County, South Carolina on the bottom right, and Quay County, New Mexico on the bottom left. Press B to go back.
Now let's take a look at how this information updates when the view changes. So in this example I'm showing here, the zoom level and the view have changed from the initial state. When users press the I key as in information, they hear spatial patterns and descriptive stats for the updated view.
Information is loading. In the current view, population density is high in the top right. Population density is low in the left. The average population density is 125.7 people per square mile. The county with the highest population density is Cook, Illinois, with 5,529.9 people per square mile. The county with the lowest population density is McPherson, Nebraska, with 0.5 people per square mile. Press L to hear the boundary of the current view. Press M to interact with the map.
So beyond enabling new interactions, users also appreciated the enhanced graphical perspective and spatial awareness. As one user put it, I really enjoyed being able to navigate and just get additional data from a graphical perspective. It gives me that kind of spatial awareness, whereas I would not be able to figure out with the drop-down box. So to conclude, AltGeoViz opens up new possibilities for screen reader users to interact with and understand geovisualizations. This project represents a step forward in making data visualizations more inclusive and accessible to all. The project code is up on GitHub. You may access through the QR code on the screen. There's also a link to the live demo, which I was hoping to show during the demo session, but unfortunately it was canceled. So if you're interested, please go ahead and check out the website. I would like to once again thank all of my collaborators, Rock, Ather, Arnavi, Jeff, and John, without whom this work wouldn't be possible. And on a personal note, I'm currently seeking for internship opportunities for summer 2025. Please check out my website and reach out if you're interested. Thank you.
Thank you. Thank you very much, Julie, for this nice presentation. I see no questions in Slido. Please, if you have a question, please post it there, so I will get started myself. Very interesting work. I was wondering, so you focus on high and low density in the maps. So how generalizable is this kind of approach to have other types of visualizations that are not density maps or so? So is that something that can be done or has been done already, or that you are thinking about doing?
For this project, first of all, thank you so much for your question. This is something that we've been also discussing internally. So for this project, the purpose is mainly to demonstrate through a quick prototype that this kind of work is possible. Currently, it only supports choropleth maps, but other types of geovisualizations such as point data, or other types, it's definitely possible in future work. There are a lot of prior work that's been done in summarizing spatial data patterns that could be incorporated into AltGeoViz in the future.
Okay, thank you very much. Thank you for your answer. A lot of challenges, I think, there. So great. Thank you very much. So we move to given the short time, we just have to move to the next speaker. So if there are more questions, please use Discord also for the questions. I would like to ask the next speaker so Ellie Holder. If I'm correct, yes. Ellie Hurd is our next speaker. He is going to talk about must be a Tuesday, affect attribution and geographic variability in equity-oriented visualizations of population health disparities. Please put the question in Slido. I see that some questions are popping up now. As soon as you have a question, just put it in because there is a bit of delay and maybe I see the questions later. And this is work together with Lace Padilla. So please go ahead and present.
Great.
Thank you, Ellie.
You can see screen and everything? Excellent. All right. Hi, I'm Eli Holder. This is a study that I did with Lace Padilla called Must Be a Tuesday. So over the past couple hundred years, public health has benefited from a number of surprising discoveries. For example, we've learned that even though it was once considered ungentlemanly, doctors should ideally wash their hands before treating patients, particularly after handling cadavers. We've learned that arsenic, mercury, radium, thorium, and cocaine are generally not safe ingredients for consumer products. We've also learned that cigarettes are not a particularly great way to treat gestational weight gain, or really to treat anything at all. Despite all this progress, we somehow still use these conventional bar charts to describe population health outcomes. And the problem with these charts is that they're maybe indirectly deadly. Our study and others suggest that charts like these can encourage harmful misbeliefs about the people being visualized. These misbeliefs have downstream effects on beliefs about health and on different manifestations of racism. These misbeliefs and attitudes and prejudices contribute to environments that are less healthy to live in. For example, counties with more explicit racial bias are associated with increased cardiovascular mortality for Black people and also for white people. These potential downstream effects suggest that charts like these aren't just detrimental for the marginalized communities being visualized, they may actually undermine population health more broadly. And so these charts aren't great, which raises our big question, which is, can we do better? Can we design better options for health practitioners? Specifically, can we visualize this data in a way that offsets blame and stereotyping by reminding viewers that outcome disparities are more reflective of social determinants and not evidence that some groups take better care of themselves compared to others or that they're somehow genetically superior? And also, crucially, can we do this without sacrificing these charts' original communication goals like calibrating risk perceptions, encouraging healthy behavior, and promoting public support? And so one way to demonstrate that we can build a better chart is to actually design a better chart. But what would make a chart like this better? How could a chart like this offset blame and stereotyping while managing viewers' risk, behavior, and support? The big idea here is reminding viewers that health outcomes can depend more on where people live rather than who they are. So this chart blames disparities on geography and not people. And it does this in two ways. First, the title says very directly, health outcomes vary widely by geography. It also calls out the states with the two worst group outcomes to tie bad outcomes to places rather than just people. And both of these are based on the theory that big, complex social determinants of health are just cognitively difficult. That is, we're biased towards personal blame, not necessarily because it's true, but just because it's easier. And so annotations like these may save viewers some effort in considering a wider set of causes for the outcomes that they see in the charts. Second, instead of just showing average outcomes for each group, the jitter plot adds some extra context, with dots representing outcomes for each US state. This makes it clear that outcomes vary widely within groups and overlap heavily between groups. And this should help address upstream social biases like group homogeneity. And we showed in a previous study that this in itself should be sufficient for reducing misattributions and stereotypes. And so our main hunch was that the GeoIMSIS chart on the left should be better than these conventional bar charts based on these two criteria sets. And so we tested a few different versions of these charts, varying heart disease versus liver disease, and whether the charts show racial groups or abstract letter groups. We also recruited even numbers of Black and white participants for each cell so that we could counterbalance whether participants saw themselves as the most at-risk groups in the stimuli or somewhere in the middle. And we asked every survey question twice, once before participants saw the charts and once after, so that we could measure both within and between subject effects. For conventional health communication goals, these plots currently show participants' baseline responses before they saw any of the stimuli charts. We found that both of these charts were surprisingly and equally effective for increasing perceived vulnerability, encouraging behavioral intent, and promoting policy support. And this is good news because it suggests that these geoemphasis charts could be a viable substitute for the conventional bar charts. And then for attribution, we asked people how much they agreed that health disparities were driven by environmental issues, access to health insurance, personal health habits, or people's genetics. We also had one question that forced participants to choose between external attributions related to where people live or personal attributions related to how they behave, to see which direction they would choose when they're forced to prioritize. And we saw significant differences between the charts for these last two measures. And for both of these, the right of the scale corresponds roughly with more personal blame. And so right is bad and left is good. We found that bar charts shifted responses towards genetic attributions and towards personal blame. And both of these are bad. On the other hand, the geoemphasis chart shifted responses towards social determinants of health, which is good. And so these effects were significant both between chart types, but also relative to participants' baseline responses. And this suggests that bar charts aren't just relatively worse, they may be actively harmful. And the geoemphasis charts might actually have a corrective effect. Taken together, it seems like these conventional charts may actively undermine public health. So in the same way that we've moved past doctors who don't wash their hands, cocaine in our Coca-Cola, and cigarettes to promote prenatal health, we should probably stop using charts like these to show population health outcomes. Fortunately, our results suggest that we can do better. Design choices like emphasizing geographic variability might actually help correct harmful misbeliefs about health disparities. Even better, supporting health equity doesn't mean sacrificing communication goals like risk, support, and behavior. This means that public health agencies could feel relatively confident in adopting charts like these in their public-facing data viz. And so we could reasonably say that equitable visualizations support healthier populations. That's
Thank
it.
you.
I forgot to thank you, but I do want to thank.
Thank you very much for this nice presentation. Thank you. So I will go ahead and ask a question I don't see at the moment. They might come later, then you can answer them also in Discord, but given the time, I have to go ahead. Sure. So I had a question. So very interesting work. So you talk about bar charts and this other representation. So how important is the visual representation itself compared to the fact that you add geographic information? So could you have another visual representation that still would give you the same output?
In this study, we weren't. It was more about kind of a proof of concepts of like a set of different changes between the two, so that we could show like there are better ways to do this. But in a previous study, we were able to suss out more of the effects of individual chart types and things like that. And so the thing that makes this one work, I think, is maybe less about the individual dots and more about the fact that it shows overlapping ranges. And so you could presumably accomplish a similar effect just showing kind of a range of outcomes kind of between the social groups. And then for the bars, the harm comes from the impression that groups are monolithic or homogeneous. And in the previous study, we saw a similar effect with using just like dot plots or just anything that shows just kind of a single indicator without variability. And so the effects there are similar effects with similar chart types.
Yeah. Okay. Thank you very much for the explanation. We have to move forward. So if there are questions, look in Discord that you can answer there. Very nice work. Thank you very much. So we move forward to the next speaker, who is Lee Mason. He's going to talk demystifying spatial dependence, interactive visualizations for interpreting local spatial autocorrelation. This is work together with Blánaid Hicks and Jonas Almeida. So please go ahead.
Okay, hi everybody. My name is Lee Mason. I am a PhD student at the NCI's DCG Data Science Group, and I'm going to be introducing a new plot design for the local Miranzi spatial statistic. So this is the example dataset we're going to be using throughout this slide deck. It is mortality data from the US state of Kentucky on the county level, and the values have been Z normalized because it makes the statistic calculations a little bit easier and the explanations a little bit easier. So the main concept we're going to be talking about is local spatial autocorrelation. So this is basically a fundamental idea in spatial analysis that describes the relationship a location has with its spatial neighbors. So you might have positive local spatial autocorrelation, which means that the location is like its neighbors. You could have negative, which means it's not like its neighbors. That's a spatial outlier. Or you may have no spatial autocorrelation, which is also known as spatial randomness. There are several statistics that are designed to detect this property. The one that you'll probably see the most in the literature is local Moran's eye. And part of the reason for that is that it's a very simple statistic. It's just the product of the focal location's value, Z normalized, and the spatial lag. The spatial lag is another pretty fundamental concept in spatial analysis, and it basically is just the weighted mean over a location's neighbors. You can weight these in all sorts of ways, but in many cases, they're just weighted equally, and then that sort of makes the spatial lag equal to just a mean over all of those neighbor values, and that's how we'll be treating it in this presentation. So here's an example calculation on this part of the data set we're looking at, giving a local Moran's eye value of 0.35. This value doesn't actually tell us much on its own. Because it's positive, it tells us that it's positive local spatial autocorrelation, but the magnitude doesn't mean anything without reference to a distribution. And we calculate this reference distribution using permutations, bootstrapping, and this just gives us something that we can compare the statistic value to see if it's significant. We can see here from this plot that the value in this case was not significant. There was no detected local spatial autocorrelation. If we did detect local spatial autocorrelation, we would basically be in one of 4 different scenarios, and we can use these to assign labels to the different parts of the data set. You might have, if you have positive local spatial autocorrelation, then you either have a high cluster or a low cluster. These are also known as hotspots and cold spots, and that's basically just like you're similarly high to your neighbors or you're similarly low to your neighbors relative to the distribution of the data set. And you can also have 2 different kinds of spatial outlier. So if we apply this to the entire data set, we can see some spatial structure emerge, see some hotspots, see some cold spots, in this case of mortality in Kentucky, and this can inform various types of analysis. So one of the problems with the current landscape for local spatial autocorrelation is that there's no really good plot that conveys all of these things together. So, conveys all the ideas, shows the relationships between them. And this would be really useful for interpretability, for explainability, and for teaching new people about the statistic. And that's what we're proposing with this plot design here, the Moran dual density plot. It includes all the elements of the statistic, and it's a little intimidating to look at first. So I'm going to just break it down piece by piece and explain some of our design decisions. So this is our example data set again, Kentucky. And the first part of the plot is a distribution over the value. So this is just a standard density plot, standard density area plot, showing the distribution of the data set. So now we pick a specific location to use as our example that we're going to plot information from. The first bit of information we add is the focal location Z normalized value here at the top with the black dot. And then we add all the values of the spatial neighbors just below that. So as a reminder, the spatial lag is just a mean over these values. So we represent that by drawing the lag at the bottom of the axis on the same axis and connecting it using these dashed lines just to show this relationship explicitly between these different values. And this is the equation for local Moran's eye. And you can see from this equation that the statistics value is essentially just directly proportional to the spatial lag. It's scaled by the focal locations value. And because of that, we can add an extra axis to the bottom that is just scaled by the Z value. And then we can draw the local Moran's eye statistic value vertically connected to that with a line. So this shows us the local statistic value and shows very explicitly this direct connection between the 2 concepts. Then on the bottom of the plot, we add another density plot. This density plot represents the bootstrapped values. This is our reference distribution. This is also why we call it a dual density plot. We've got density on the top, density on the bottom, dual density. And with this density plot on the bottom, we can calculate the critical values and add in some significance regions. So these are basically just regions that if the blue sort of features here, the blue bar, the blue dots, if they fell in those regions, then we would assign that location that label. In this particular example, we would just assign a not significant result because we fall outside of those regions. Here's an example where we fall into the high region quite clearly, and this location would therefore be assigned to a high cluster. And here is one of the caveats of this plot, is that if we have a negative Z value, we have to flip the bottom axis. So it's mirrored, as you can see there from the direction of the arrow and just the 2 axis labels at the sides. we have to mirror these things because the Z value will basically flip it because it's negative now. And we want to retain this vertical clear relationship between the two concepts. But because we use color, because we use labels, and because the labels are different anyway, we don't think this is going to confuse the viewer. And some of our initial testing showed that it didn't. This is, quite clearly indicating what label you're being assigned to and why. So part of the sort of core idea of this plot is that it includes everything that's relevant to calculating a local Moran's-I statistic, and it's kind of it's drawn in a way that sort of situates it from top to bottom in terms of a flow from your data, from your Z values, from your neighbor values, into your spatial lag, and down into the statistic value, which is your results. So you go from data at the top, results at the bottom, and you have everything you need to interpret the specific local Moran's-I label that you give it, including, okay, what's pulling it down, what's pulling it up in terms of the neighbor values, and what leads to the specific label assignment. It also represents some of the less intuitive aspects of the statistic, such as the fact that the Z value of the focal location doesn't actually contribute to the significance, as we've seen here. It doesn't flow into the bottom of the plot. This is a counterintuitive element of the statistic, and it's just the way that it works by calculating the p-values. And we hope that this plot shows this a little clearer than existing visualization designs. So this is just one of the 3 designs we introduced in this paper for local Moran's-I analysis. I didn't have time to include them all in a single presentation, but if you're interested in learning more and interested in seeing all these things interactively linked together in a dashboard and learning about a JavaScript library we made, I would encourage you to visit this link, which has a dashboard and also links to an observable notebook explaining the other plot designs and explaining the JavaScript library. Okay, so that's my presentation. Does anybody have any questions?
Thank you very much. I will go ahead given the time, and there is no question at the moment. So I was wondering, for these statistics, right? So you say that it didn't matter if you that people could understand that the thing was swapped or not. So how did you test that to see that the people could understand that?
So we had a test set of 5 different people, and we asked them basically just to look at the statistic and interpret it as quickly as they could. And 3 of those people were complete laymen to the spatial statistic. Part of the reason we wanted to do this was to teach new people about these ideas in a clear way. And yeah, they said that they very clearly understood that the assignment was related to these areas. And they were looking more at the areas than the specific details of the bottom plot, of the bottom axis. And that was the important information anyway. So we think it achieved that. But yeah, further testing would be needed to confirm that beyond like a small sample of people we asked.
Okay. Yeah, so another question I would have is, could you use that in other things that is not just geographical maps? So I can think about some methods that are being used, for example, dimensionality reduction or things like this, where you have neighborhoods. And could this kind of measures also be applied there, or?
Yeah, I mean, but anything that has a spatial component to it could be, you could do local Moran's-I analysis on it. And you could use these plots in anything that has this kind of directly proportional relationships between these 2 things. So you could use this in other scenarios as well. And yes, you could definitely use it for other types of data than just geospatial data.
Thank you very much. Given the time, I thank you. Please look at the questions come sometimes later, so just you can answer them then in Discord. So I would like to move to the next presenter. This could be Max Franke. So he's going to present 2-point equidistant projections and degree of interest filtering for a smooth exploration of geo-referenced networks. Quite a long title. This is work together with Samuel Beck and Stephen Koch, and I give the floor to Max. Thank you very much.
Thank you. Yes. So hello, my name is Max, and I will be presenting on behalf of my co-authors as well. And I also want to thank the various students who helped us in this work. Okay, so geo-referenced networks are relevant for many research questions. These networks are often semi-hierarchical in nature with heterogeneous distribution of locations and local, strongly connected clusters that are hard to see in an overview. Previous work, such as that of Broadcorbett colleagues, has explored overview plus detail approaches here to show such networks. Other work, such as that of Ghani and colleagues, explored focus plus context approaches with a geographical ego perspective. We extend existing work by including animated zoom and pan transitions between graph nodes to combine a geographical ego perspective with more geographical context. We use a zoom and pan transition here, which shows both origin and destination at some point. In addition, we utilize degree of interest functions to decide what other locations to show during transitions. Generic degree of interest functions here can, for example, be the degree of a vertex in the graph or its topological distance to the current viewpoint. In our first prototype, we used Mercator projection for its familiarity and its ease of implementation. However, for a zoom and pan transition between two geographical locations, our projections might be more suitable. In particular, we consider azimuthal equidistant projection, which preserves distances from one chosen location, and two-point equidistant projection, which preserves distances from two chosen locations. And by using one or both of the transition's endpoints as projection nodes here, we can ensure that geographical shortest path between the two locations is represented as a straight line without distortion. And this seems like a desirable trait for this type of transition. Our second prototype, which we show on the left here, uses two-point equidistant projection for the animated zoom and pan transitions between two locations. Locations of interest outside of the viewport are indicated by small circle maps at the edge of the main ego perspective map pane in the direction toward the indicated location. Clicking on one of these proxy maps will initiate an animated zoom and pan transition to its location. Here, we use the zoom and pan transition path as suggested by Van Wyk and Nye. On the right side, you can see the viewport of the transition over time. We performed a comparative evaluation of the three projections. In a preliminary study, we compared the projections regarding three tasks. First, understanding the distance covered by an animated transition. Second, understanding the direction traveled. And third, identifying the destination. Our stimuli had 4 difficulty levels, which we controlled by the distance covered by the transition. The result of the evaluation was the time needed to solve a task as well as the error. Participants had to solve our 3 tasks on a virtual 3D globe. However, we noticed that participants had difficulty gauging distance properly and were just memorizing the destination point in the transition instead of following along the entire transition to solve their tasks. As a consequence, we only used the direction task in the actual study, which we carried out as an online study on Prolific. After removing participants who failed their attention tests, we were left with the data of 72 participants. Participants were shown an animated transition between random points as a video, as shown here on the right side. Afterwards, they had to answer what direction the transition had taken on a virtual globe. Since we had noticed that participants memorized the geographical landmarks to solve tasks in the pre-study, the globe shown here does not have any geographical features. We carried out time and error analysis with the sample mean per participant and condition, using interval estimation with 95% confidence intervals. These intervals are estimated using bias-corrected and estimated bootstrapping with 10,000 iterations. From here, we calculated the pairwise differences between the projections per difficulty with Bonferroni correction for multiple comparisons with a factor of 9. These pairwise differences show few conclusive results, but we can see some weak evidence and trends. First, there is weak evidence for lower error rates for azimuthal equidistant projection over 2-point equidistant projection at larger distances and a trend towards that conclusion at lower distances. Second, there is a trend for Mercator projection having lower error rates for smaller distances than the other two projections, but performing worse at distance levels 3 and 4. There is even weak evidence for azimuthal equidistant projection performing better than Mercator projection for distance level 4. Third, regarding time, there is a weak trend for Mercator projection being quicker for small distances, and the other projections being quicker for larger distances. In total, the participants found the direction task quite hard to solve, but especially so for the azimuthal equidistant projection. In conclusion, both our evaluation and informal feedback revealed that Mercator projection is hard to replace, both because of its familiarity and its ease of implementation. However, we found two-point equidistant projection and an azimuthal equidistant projection to be promising candidates for animated transitions, especially over large distances. Transitions on 3D globes might also be interesting candidates here. We see a lot of potential in exploring degree of interest functions and especially domain-specific functions in the context of ego-perspective exploration of geographical data. Our evaluation also hints at an interesting connection between prior geographical knowledge and a sense of scale, which could be explored further in a follow-up study using artificial map data. With that, I want to thank you for your attention. Be sure to take a look at our code and at our pre-rendered prototype. Thank you.
Thank you very much. So we are short in time, so I will have a very fast question. So if we look at slide 7, you are showing, oh, you removed the slides. So there is, if I look at the projection, azimuthal projection compared to the Mercator projection at the end, it seems that there is a bias of overestimation and underestimation depending on the method you are using. So it seems that depending on the projection, the users have the tendency to overestimate the distance, while for others, they have the tendency to underestimate the distance. Did you look into that? Is there a reason for that?
We are not 100% sure, but we think this is because of the distortions that Mercator projection introduces over larger distances. So users are quite confident with Mercator projection for shorter distances, and they are quite correct in their estimations there. But for larger distances, they tend to overestimate how far things are in Mercator projection.
Yeah, it seemed that they in the task 4, in some they overestimate and the other underestimate, clearly more or less the same quality, but one overestimate and the other underestimate. Okay, thank you very much. So more questions can be given in Discord, and thanks for your presentation, Max. So
Thanks.
we move to the next speaker now.
Yep.
This is, sorry for the pronunciation, Heer Kim. I apologize for that. So he's going to talk about bringing data into the conversation, adapting content from business intelligence dashboards for threaded collaboration platforms. And this is work together with Arjun Srinivasan and Matthew Bremer. So please go ahead.
Thank you. That was actually great pronunciation. Hi, I'm Hyag. I'm a postdoc at University of Washington. Today I'm presenting this work on retargeting dashboard contents for collaboration platforms on behalf of my colleagues. And I also note that this work was done at Tableau. We have lots of conversations on collaboration platforms like Slack or Teams because they offer synchronous or asynchronous, distributed, and threaded conversations that can be enhanced with third-party extensions. These functionalities are also useful for us to communicate data over these collaboration platforms. When we do communicate about data, we don't just do it by saying about it, but we show the data within a conversation by sharing data artifacts like a visualization, table, and some summary statistics. In doing so, there are several things to consider from the perspectives of different participants in a conversation. Particularly in an organization, different people have varying roles regarding data work. Data professionals who usually share data artifacts would want to easily make those while being able to flexibly select only the parts they want to share. Consumers of those artifacts would prioritize how easy it is to access those artifacts, and both participants would appreciate if a data artifact respects their data lifecycle. For example, you could just take a screenshot of your dashboard. It's super easy and to create and see them. However, when it comes to adding annotations, reformatting it for a glanceable look, or enabling updates and satisfying security policies, screenshots are not so an ideal option. Instead, you could share the URL of the data source, which is extremely easy, and it makes it possible to use whatever data policy is embedded in the data source. However, when it is really hard to consumers to navigate a complex dashboard, it requires context switching between different applications and does not really support mobile devices where many users are on. Some might recreate another dashboard for consumers. However, this is highly laborious given that data professionals are not necessarily able to create dashboards or other complex data sources, and it also forces to switch between data and conversation. So to overcome these challenges, we propose Dashboard Snapshot as an embeddable data artifact on a collaboration platform. Dashboard Snapshot refers to an artifact that communicates a selection of one or more elements from a dashboard at a given point in time. In designing Dashboard Snapshots, we had the following considerations in mind: be specific and transparent about how a data professional has made a selection from a dashboard and what caveats are entailed in the data at that moment. Be context appropriate, considering factors like visualization literacy of consumers. Lastly, be time sensitive so that an outdated snapshot does not lead to any miscommunication. To enable this dashboard snapshots, we present 6 strategies in terms of scoping, context, templates, curation, data caveats, and updating. These strategies are implemented as a set of prototypes for retargeting a single dashboard selection and for combining those multiple selections into a single snapshot. These prototypes, along with a dashboard application and a collaboration platform, are backed by a formalism, which is also detailed in our paper. First, snapshot creation should allow for flexibly selecting any portion of a dashboard or across multiple dashboards if they are related. For example, from a dashboard, a user makes several selections and they are combined as a single snapshot. Next, a snapshot should be able to provide affordances for adding situational context, for example, through annotations with corresponding captions, simple Q&A interactions, which generates a private filtered view, and this can be done in the single-piece creation interface. Next, to support consumers with limited expertise in data literacy or to add more details for the context, data professionals need to reformat the original design. To make it easier to do so, we suggest using templates that are designed to support different tasks like comparison between values or comparison a value to a reference value. Alternatively, an original design could include important communication-wise features such as a color palette that is familiar across an organization. In that case, it should also respect that decision of preserving the original format. This is supported in the single-piece authoring interface. A snapshot could deliver more structured data stories or rich backgrounds for those who get more engaged. In that case, the snapshot needs to consist of multiple components, and those components need a curation methods, such as interactive carousel or automated slideshow or a mini dashboard. Next, data entails some caveats. For example, it might be only valid until a certain point in time. It could include some missing data points, or there could be some filters applied by the data professional who created it, and this information should be communicated transparently to not cause miscommunication. Lastly, a snapshot becomes outdated, that we need to create an updated version. And to make it easier to do so, our snapshot interface allows for scheduling an automated update or letting others to update it. This concludes my presentation. To get more details about our implementation of strategies and backing formalism, please visit our detailed technical documentation. This also includes a video demo of our implementation based on a use case. Thanks so much.
Thank you very much, Hyuk, Kim. So I will ask a question myself. Maybe somebody still will have a question. Yeah, so I was wondering, so you present a system, what are the main factors in this system that differentiate it from, for example, using Tableau or so? So what are the main features or parts that you have in this system that facilitate the collaboration, which I understand is what you are mainly, or the conversation, that is mainly what you are doing, right? So if you want to separate from other kind of systems that do generate visualization, what is the main difference, would you say?
So yeah, for example, given a Tableau dashboard or Power BI dashboard, they are not so like easy to read or see in a collaboration platform. Like when you do a Slack, like when you do like send messages on Slack and then you see a dashboard like just popped on your conversation channel, sometimes it is too complicated to look at. So in that case, you want to like reformat it so that you can share only the part that you want to communicate to other people in your team. Then the dashboard users are not so like not necessarily super great at creating new dashboard or like creating other like data artifacts. So it sort of gives an interface that they can easily select what they want to share and then generate a format that is more suitable for like conversations happening on more text-based chats.
Okay, so it's okay, good. Yeah, thank you very much. Given the time, I'm afraid I have to move forward. So maybe some questions will pop up.
Thanks.
And then you can answer them also in Discord. Thank you very much for the nice presentation.
Thanks so much.
So I would like to ask our last speaker, last but not least, Magdalena Boscher, who is actually an honorable mention of the short paper. So Magdalena is going to present her work on the comic construction kit, an activity for students to learn and explain data visualization. She's going to present a work together with, developed together with Cristina Stoiber, Mandy Keck, Victor Adriel de Jesus Oliveira, and Wolfgang Eigner. And said that, I give the floor to Magdalena. Please go ahead.
Yeah, thank you very much. My name is Magdalena Boscher. I'm a PhD student from St. Pölten University of Applied Sciences and TU Wien, and I'm happy to present our work on behalf of my colleagues. So our base idea came from a research project where we are looking at different pedagogical methods and learning materials that can be used to effectively teach data visualizations in middle and high schools. And our results so far echo those of the other researchers in the community, showing how important it is to incorporate hands-on, interactive, and creative experiences into visualization classes. And among other media, we investigated comics as a learning tool for data visualization topics because their step-by-step nature has been shown to be very well suited to tell stories, share insights, or explain processes. However, most of the time, comics are more of a passive medium, crafted by experts for learners. But a few workshops have already tried looking at it from the other side and made participants create their own comics, for example, for creating comics to learn about data-driven storytelling. So we thought we can use this potential and make a workshop activity where learners explain how to read or construct various types of visualizations in a comic format, kind of mirroring a learning by teaching approach, which has been shown to be an effective learning strategy already. Now, we had experience with other creative workshops or lectures before, and one common obstacle was always that participants were hesitant to actually draw, saying they can't draw, or they have difficulties coming up with something in such a short time, or they were just nervous to sketch in front of other people. So we created what we call the comic construction kit, which consists of a comic grid of panels. Then optional pre-printed data visualization examples, and if needed, matching cheat sheets that shows the data visualization. And most important, a sheet of stickers with ready-to-use comic materials. And I could, for example, now go ahead and take this comic that I've prepared and say, okay, I want to talk about an area chart. And here I have this big area chart, so I need a big panel, so I can just go and make this big comic panel that spans over 2 of the grid spaces. And then maybe I could say, yeah, I want to point out a certain path here in the area chart. So I can take a sticker and, for example, this one that just nicely points to something and put it here on the chart and say, yeah, there's a peak. And maybe I can even take a speech bubble that's already written text on it and then put it here on the chart. And maybe you've noticed that some characters don't have faces. That's because depending on the situation, you might want to draw own faces for your characters. So you could just go ahead and make a face for your character. Yeah, and we did this workshop a total of 8 times with very different target groups, from data visualization researchers, then middle and high school teachers and students, and university students of both bachelor and master level. And with each workshop, we refined the details based on what we learned from the previous iterations. All workshops were between 80 and 100 minutes long, and in total, we had 105 participants who produced 40 comics. We ended up with 2 slide variations of the workshop, which we call version A and B. So in workshop A, we first took 10 to 20 minutes to introduce participants to the chart types in focus. We explained the tasks and introduced the comic construction kit. And then 1 hour was dedicated to participants actually making their own comics with the kit. And 2 to 3 workshop conductors roamed around the room to answer any questions that came up. And people of all age groups really became creative, especially with the stickers. So, for example, people noted that the predefined poses gave them creative story ideas they would not have come up with on their own. So, for example, they would just take a standing character and transform it into a sleeping one by just flipping them around and drawing a bed under them. Yep, and at the end of the workshop, we took 20 minutes for a show and tell session where we had a mobile camera to go from group to group and project their comics to the front, and the groups then explained their comics and the main decisions that they took. And with workshop B, we were looking to integrate the workshop better into an actual semester-long dedicated data visualization course. And hence, before the workshop, we asked the students to first research suitable chart types from the course's reading list. This replaced the introduction of the chart types that we had in workshop A, but the introduction to the comic kit and the actual comic construction activity remained unchanged. And in the end, instead of a show and tell session, we asked the student groups to exchange their comics so each group could learn about different visualization types. We collected both qualitative and quantitative feedback, and the qualitative feedback was very uniform. So people especially mentioned how convenient the materials were, that they found the activity very engaging and immersive, so they felt that time passed really quickly. And people of all ages really liked the stickers and even expressed their own workshop ideas. For the quantitative feedback, we asked 8 questions. The first 6 focused on the creation of the personal comics, and the last 2 on the interpretation of the other group's comics. But in the interest of time, please, if you're interested, look at our paper, it's all there. But in general, after all the iterations of our workshops, we can summarize that people found the activity really fun and engaging. And while they often started coming up with very elaborate stories that they couldn't fully finish, it is worth noting that they, in fact, did finish a simple comic in just 60 minutes. And what was also very interesting for us as instructors was that we were able to see where students still had difficulties or knowledge gaps. For example, there was a group of students that tried to use temperature data to explain an area chart. And after quickly speaking to us, they realized their error and even incorporated this personal light bulb moment into their comic then. Of course, though, there are some limitations to our workshop. The biggest one was probably the missing control loop before students switched around their comics. So some groups got less developed comics and could not benefit as much as others. But we're positive that if one were to use the full course framework and add a feedback loop, not only the creation of the comics could serve as a learning activity, but all comics created by everyone in the course could be collected to form a collaborative course comic book, for example. So yes, all our materials are open source and free to use for anyone interested in replicating our workshop. All resources, including an activity sheet with detailed instructions, are linked in our paper or with this QR code. And with that, thank you for listening. I'm open for any questions.
Thank you very much, Magdalena. Thank you for this nice talk and a very good use of the fact that we are doing this virtually, right, with the camera. And so, yeah, so the time is getting to an end. I would have maybe some question. I see there is a delay. I don't have a question is Lido, but I see in Discord there is active discussion. So please go there afterwards. Yeah. So one thing I was wondering is how difficult it is to generate new graphs or new kind of visualizations that you would like to use in this context? Because I guess you have some predefined ones.
Yes, in our case, we used predefined ones that were rather easy for students to understand. But you could totally create your own or just use the ones from your course. So I think just taking data and visualizing it with anything like Tableau or any other tool and then printing them in various sizes would just be perfect.
Would it be also useful for the students that they could modify these visualizations somehow? Did you have this possibility that they could maybe create them themselves rather than predefined?
Yes, we had some students in one workshop, they had their own visualization types. And in that case, we stayed traditional and they drew the visualizations themselves. So some, for example, explained the parallel coordinate chart and then just sketched one instead of printing them out, running to the printer, cutting them out and putting them on the comic. So we stayed traditional.
Okay. Thank you very much. Yes. I want to thank Magdalena, but also all the other speakers of this session. Thank you very much for these nice presentations of your papers and the short discussions that we can have. Please, I think in Discord there is also active discussion, so please go there and go on. Thank you very much, all of you, and yeah, see you.